Hi everyone, welcome to this physics class where we are going to learn everything about force. So we are going to learn what is a force, and I'm going to make the concept of forces absolutely clear for you. So are you ready to begin with a punch, which is a force? Let's get started. Before we begin, just a quick reminder, do check out the courses on our website manochaacademy.com and our Android app. All the links are given below, and please do share it out with your friends as well. So before we talk about forces, let me ask you a couple of questions and you guys tell me the answer in the comments. Okay, here's our first question. So why does it feel harder to pedal a bicycle when you're going uphill, right, as compared to a flat ground? So take a look at this question and tell me the answer. What do you think is the answer in the comments? There's no perfect or right or wrong answer. So I want all of you to think, apply your minds, not artificial intelligence, your human intelligence, and tell me what do you think is the answer here. What is the reason? So we know that it is much more difficult to ride uphill, right? To ride the bicycle uphill as compared to flat ground. Why? Because it's like this invisible force is pulling us down, right? It is like there's something invisible pulling us down over here. So we can say something here, something magical, something invisible, which we're going to call force, is pulling us down. And this you can say is the force due to gravity. Or some of you might be thinking that there is friction, right? There is some friction force you have heard about on the tires. So that is also making us harder to go up, right? So think about it. Another question. Why is it easier to slip on a wet surface? We suppose there's a wet surface, right? Like, and especially, if it's like marble or granite and there's water, zoom, you will slip and fall down for sure. Okay, we have to be very careful when we walk there. Why? Whereas normally when you're walking on the floor, or let's say on the ground, or the park, sand, you don't slip. So there is something happening over here, right? And basically you have heard about that thing, friction. We'll be talking more details about friction in the next class, but here that the ground, when it is slippery, the friction is less. That's why when you step on a banana peel, zoom, that comical or Tintin moment, right? You fall down. So this is where we are talking about the friction force is less. I'm just telling you some words. You have heard about this, right? Friction force is less, and so we tend to slip, correct? Another thing, you have seen that we feel light, or we feel like we are floating just after the swing reaches its highest point and begins to come down, right? So you love this floating feeling when you're on a swing. You guys have experienced it, right? So next time you're on a swing, think of physics, right? So why, of course, enjoy the swing, but why is this happening? Because you're sort of in a free fall, you're falling down, and again, who's pulling you? That's right, the force of Earth's gravity, right? The gravitational force. So you can see this is the play of forces happening over here, and that's the topic of this class. So what is a force? Okay, let's take this example. Why don't you do this activity right now? Let's say you have a box or a book, right? Take a book or a box, something right in front of you right now, and I want you to do this, right? Give it a push. What will happen? The box will move. Try to pull the box like this, right? Pull the box like this, again it will move, right? Again give it a push this way, or you can even try lifting up the box. So I want you guys to try this right now and see what are you doing. You are basically applying a force on the box, we say, right? Or basically what are you doing? You are either pushing the box this way, right? Or I can say I'm pushing the box this way, or I can say maybe I'm pulling the box this way, or maybe I'm pulling it upwards. Some of you might be trying to push it downwards. I don't know what you're doing, you tell me. So you are basically applying a force on the box, right? And what really is force? Force is nothing but, can you see, you're either doing a push or a pull. Is there any other thing we can do? Probably not, right? A push or a pull. So the scientific definition of force is basically very simple. I just love this definition in physics. The definition is very simple, that force is nothing but, force is a push or a pull. As simple as that. Force is defined simply as a push. So either you're doing a push or a pull. Correct? So just like we discussed, you are using your hands, you're either pushing the box or the table or the chair, whatever object, right? And you're applying a push or a pull. Clear? Now can you guys tell me what is the unit of force? Unit means, since force is a physical quantity, we want to measure its unit. Physical quantity means, you can say roughly quantity in physics, but basically what we use to define laws in physics, right? So force is definitely something we are pushing. You can say that I'm pushing very hard, or I'm pushing very gently or soft, right? So a heavy push or a light push, but that's very rough, right? So we want to give some value to it, some measurement, and that is why we want to define a unit. So do you guys know what is the unit of force used? And here typically you know that SI system is the most popular right now, right? So what is the SI unit of force? Who can tell me? What is the, I am asking the SI unit of force. Tell me guys in the comments. And those who have written Newton is absolutely the correct answer. So did you write like this? Did you write Newton? Well, if you have written like this, then you are writing the name of the scientist with capital N. No, I don't want that. The unit is written, write it down right now with small n, not capital N, right? So the unit of force is actually written with small n. Please make a very important note. Your textbook also says that. All the good books say that. Sometimes they make a typing mistake, right? They write capital N. No. Unit is written with small n, and the abbreviation we write with a capital N, right? So I can say I'm applying a force of, let's say, 5 Newton on the box. So I will write like this, force equal to 5 Newton. So abbreviation capital N. Is that clear? SI unit is, it is measured in Newton after the famous Sir Isaac Newton. Okay, one more question. Does anybody know what is the CGS unit? Remember I have talked about these, there are these two unit systems. There is the SI unit system, which is very popular. CGS is also popular. Does anybody know what is the CGS unit of force? Come on, put it in the comments. Put it in the comments. So this is just for your extra knowledge that CGS unit is dyne, D-Y-N-E. Okay, you will hardly use that much in class 8, you know, but the main thing you need to know, this for the little extra stuff, it is Newton. In fact, Newton is much bigger. 1 Newton is 10 to the power 5 dyne, or you can say 100,000 dyne. So Newton unit is much bigger. Okay, so what you guys will remember, that force is nothing but a push or pull, and the unit used here, the SI unit, the main one, is Newton. Now guys, can you tell me what can a force do, right? So what can a force do? Let's try with this, let's try to fill in this simple table here. So suppose a bicycle is moving, right? So suppose a bicycle is moving like this, right? Or a moving bicycle, suppose your friend is coming, right? And then your friend's bicycle is going and you want to stop the moving bicycle, right? You want to stop it. So when you're holding, let's say the bicycle is going this way and you're holding it, right? Then what is the type of force? Type of force means, are you applying a push or a pull? So think about it, visualize it guys. So bicycle is going this way and you are trying to stop the bicycle. So what is this action you just did right now? What is the action you did? That's right, do you guys agree? The type of force is a pull. We are pulling the bicycle to stop it, right? Or suppose our friend is going and we say, don't go, don't go, don't go. We are pulling the bicycle back. And so what is the effect? What is the effect that we are having on the bicycle? Can you guys tell me? So when we are pulling a moving bicycle, we are basically trying to decrease its speed, or we are trying to stop it, right? So we can say, what are we trying to do? Reduce the speed or decrease the speed or bring it to a stop. So that is our effect. Force has an effect, right, on the object, on the bicycle here. So we are applying the force and the object is on the bicycle. Okay. Now let's say hitting a moving ball with a bat. right? So IPL is going on, right? Or I'm a big fan of cricket. Do you guys like cricket, right? So let's say a ball is coming, right? And then you hit it with a bat. A ball is coming and you hit it with a bat. So is this a push or a pull? Think about it. Ball coming, you're hitting it with a bat. So basically the bat is pushing the ball. Very good, very good. So we can say this type of force is definitely a push. And what is the effect going to be? What is the effect on the ball? So imagine the bowler is bowling like this, right? And who's your favorite cricketer? Let's say Virat Kohli hits it for a 6, right? So Virat Kohli hits the ball for a 6. So ball was coming this way, he hits it. What is he doing? He's changing the direction of the ball. Now he could also be increasing the speed of the ball, right? So here one of the important effects is change of direction. You can change the direction of the ball, or we can say we can change the speed of the ball. Make sense? So that's what's happening here when you hit a cricket shot. Next one, pressing an inflated balloon. So let's say you have got a balloon. Inflated balloon means it's blown up. So you've got a balloon here and you are pressing it, you are squeezing it. So what is the type of force? Is it a push or a pull? You see it, right? Imagine this is a balloon, you are pressing it. So clearly this is a push. So the force that we are applying on the balloon is definitely a push. And what is the effect having on the balloon? You are squeezing the balloon. So basically you are changing its shape or size, we can say, right? So what we are doing is we are changing the shape or size of the balloon. Okay. So here for type of force we have used push or pull, right? And the effect of the force. The effect the force is having on the object, these kind of effects. Is that making sense? Does that make sense? And here you guys can take a look at this table I've got filled in here. Let's see if you got the correct answers. So holding a moving bicycle, right? Of course the bicycle is coming, you could also be pushing and stopping it. That's also a possibility. But let's say it's going this way and you're trying to pull it back. It's going that way, you're trying to pull it back. So this is clearly a pull and you're basically stopping or decreasing the speed of the bicycle. Okay. Hitting the moving ball with a bat, you're clearly pushing. And one of the main effects here is you could change its speed also, but changing the direction of the ball. And the last one, when you're pressing an inflated balloon, you're basically changing the shape of the balloon, right? Changing the shape, or you can say changing the size of the balloon. Okay, so these are all the things which a force can do. So whether we know it or not, we are using forces all the time in our daily lives. You think about it, I'm guaranteed you're using forces, right? So for example, when you open your drawer, right, or you open your cupboard, what are you doing? You're pulling the drawer or you're pulling the cupboard doors open, right? So clearly you can see that we are applying a pull over here. And push or pull we know is nothing but force. So pulling the drawer, definitely when you take a rubber band and when you stretch it, and when you stretch it, is it a push or a pull? Think about it, you've got a rubber band, you're stretching it. So it is clearly a pull. This is also a pull. Stretching a rubber band, you're applying a pull force from both the hands, right? Fielder stopping a ball, right? So suppose you know the ball is coming and I catch the ball like this. What is my force? Is it a pull or a push? Think about it. The ball is coming this way, the ball is coming this way, and then I stop it, right? I stop it. So I'm basically applying a push on the ball, not a pull, right? A push. So here you can say when we are stopping the ball, we are applying a push. Or a player kicking a football, he's certainly not pulling the ball, he's pushing the ball with his foot, right? Kicking the football. Soon FIFA World Cup is going to start, right? So he's pushing the ball. Next one, applying brakes on a bicycle. So what will that be? So when you're pulling, right? When you want to stop, you're applying the brake, you apply a pull force, right? You apply a pull force on the brakes. So here, whether a moving bicycle is going, you're pulling the bicycle, or you can even talk about the brakes. The application is, it's a typical pull force, right? So here applying the pull force over here. Let's say when you're turning the auto rickshaw, the auto rickshaw or the bicycle, when you're turning it, right, the handle, what is the type of force you're applying, right? So you're applying basically a pull here, right? Let's say pull. So again, it depends whether you're pushing it this way or pulling it. Depend. When you're rolling a chapati, right? When you're applying the rolling pin, you're rolling the roti. So basically, you're applying think about it. You apply pressure downwards, and there is a kind of a push over there, right? So whenever you're applying a push or pull, remember this chapter that you are applying a force. So right now, when I'm writing this word push, what am I doing? I'm applying a force from this marker on this digital board. What type of force is it, guys? What type of force? It's a push, right? So right now there's this chair over here. So if I go ahead and pull the chair to myself and I say, let me sit down here in the class. So I pull the chair. Or I say, no, I'm not going to sit down. I'm going to teach. So I take this chair here and see, I'm pushing the chair. I'm pushing it away. So all the time we are doing these forces, whether we know it or not. Like Earth's gravity is pulling me down. Otherwise, sir would be floating in the class right now, right? Earth's gravity is pulling me down. So if you are observant and you see what's happening around you, you'll clearly see we are applying forces all the time in our daily lives. Now this is a very important part, and always questions are asked that what is the effect of force? Remember, we did some examples when we talked about this table, right? So this was the effects, this was the type of force, right? We are also going to study type of force in a different way, contact and non-contact forces and all that. That we'll do in the next class. Today's type is very simple. The definition of force itself, it's either a push or a pull. That's the definition today, right? So that was the type, and here is the effects of force. Now let's write the effects of force nicely. Okay. So with this visualization, you can see that what are the effects of force. So when we apply force on an object, what is one important effect it can do? It can basically make the object move from its rest position. So suppose the ball is at rest, right? The ball is at rest and the footballer kicks it, right? He is making the ball move. Or let's say the chair is at rest and you push it or you pull it. You are making the object move which was previously at rest. Is this clear? So this is one thing. Next, what is the effect you can do? What is the effect you can do? You can change the speed of an object if it is moving. So let's say a ball is moving, right? And the footballer kicks it hard, right? So he can change the speed. Definitely what he can do over here, he can change the speed if it's already moving. Make sense? Or like we discussed the cricket example, the ball is coming and Virat Kohli hits it there. So he has changed the direction and the speed in that case. Or let's say a ball is moving and then you make it go faster this way in the same direction. So you are changing the speed, or you tend to slow it down. So change of speed can be increase or decrease, both. Okay. Then what else? So like we discussed the cricket example, we can change the direction. So when we hit the ball in a different direction, or the footballer, a moving ball comes and he hits it in the other direction, he is basically changing the direction of the object. Does that make sense? And then what else you can do? And here when we said we make an object move from rest, or I can add over here, or stop a moving object. So let's say the object is already in motion, right? The ball is coming and you stop it, right? Or like the fielder catching the ball. So that is an example of the effect of force. And then you can also bring about the change of shape. What are our examples? Like we talked about the balloon. You squeeze the balloon, right? You are decreasing its size and changing its shape. Or you take a rubber band and pull it, or you take a spring and pull it or compress it. So we can definitely change the shape of the object. Changing shape of the object is also an important effect of force. So here are the main effects that we can talk about. See, make an object move from rest or stop a moving object. Number 2 we discussed, change the speed, increase or decrease the speed. Number 3 we talked about, change the direction. Number 4 is change the, or your effect can be doing some or all of these effects. Like that Virat Kohli example I told you, he is changing the speed and the direction. And when he hits it, maybe slightly changing the shape of the ball also, just for a short moment, right? So it can be multiple things also. It need not be only one effect. There can be many effects of force. Effect means what does the force actually do to the object that you are applying the force on. What is the effect of it? So let me ask you this question. This is the question, that does change equal to force? So what do I mean by that? So does this mean that whenever there is a change in speed, direction or shape, right? So if you see that there is a change in speed or a change in direction, right? Or let's say a body starts moving or change in shape, is a force acting? Can you guys tell me yes or no in the comments? Come on, try it out. So this question is asking that if you see a change in the speed of the body or the rest or motion, right? The state of rest or motion, or the direction change or the shape change, is a force acting on the body? Yes or no? Tell me in the comments. So the answer, guys, is a big yes. It is a big yes, because that is what we learned, this very important thing, that is the effect of force, right? So if we see its effect, that an object has moved or stopped moving, there's a change of speed, there's a change of direction, or there is a change in shape, if we have observed the effect, there must be a cause. And who is the cause? That's right, force. So who is the cause over here? Cause is the force. The cause-effect relationship. Only when there is a cause, there is an effect. So the answer has to be yes, because force, please remember students, is the cause. Okay. Now here if we see, suppose we see something is at rest over here, like this apple, you can see, right? This tasty apple sitting on the table. So suppose an object is at rest like this. So here we don't see any change of its rest or no change in its state of rest. That means it starts moving. So the object is peacefully at rest. Does it mean that no force is acting on this object? What do you guys think? Again, I want you to think. It doesn't matter if your answer is right or wrong. Think and tell me in the comments, do you think that there is no force acting on this apple? What do you guys think? So students, be very clear. When you saw a change, when you saw an effect of force, you know that the cause is the force. But here basically what is the thing? We are seeing no effect. Means the apple is peacefully at rest. I'm not asking you to pick it up and eat the apple. No. You say, sir, an apple a day keeps the doctor away. Very good, very good. But right now the apple is at rest. Nobody is picking it up. Okay. So the question is there zero force on it? Is there no force acting on it? The answer is no. Because we know that this apple is sitting on a table which is on the earth, and we know Earth's gravity is pulling it down. So definitely, guys, there is a pull, and pull we show in this physics, right, with the help of these arrows. So we will say definitely there is a force of gravity pulling the apple down. But then the question is, why doesn't it fall down? You say, sir, there's a table. But table means, why doesn't it, go through the table? You say, sir, table is strong. But strong means, see, there is an invisible force pulling the apple down continuously. You don't see the force, or you don't say, gravity, please start. No, it is continuously pulling it down. Simultaneously, guys, magically, there is also a force acting by the table, right? So acting by the table on the apple upwards. So, or maybe I can draw it here also. There is a force acting by the table on the apple, pushing it upwards. Are these two forces equal? The answer is yes. So if this is 5 Newton, this is also 5 Newton. Note that. So if the gravity force was 5 Newton, this will also be 5 Newton. And that is why the apple is sitting peacefully and meditating over there. It is not moving at all. It is perfectly at rest, because even though there are forces, right? So there are forces, you agree, gravity's force is there, and there is this force by the table on the apple. Some of you may know the fancy science word, like this is called force of gravity. This is called normal reaction, right? An upward normal reaction by the table. Anyway, that's a fancy word. We'll talk about those later. So these two forces will cancel each other. Okay. So this is very important. So we cannot say that no force is acting. No. So I'll write here, no, there can be forces. But in the apple's case, the two forces cancel each other. There are forces. You can see there are two forces, gravity and the normal reaction, but the two forces cancel each other. So when the two forces cancel each other, I can say the total force or the net force or the resultant force or the overall force is 0. Whatever beautiful words you use there, we can say that basically, guys, here the net force, do you guys agree, is 0? Because 5 minus 5, why is it cancelling? Because in opposite direction. If it is 5 plus 5 in same direction, then they add up, right? So they're cancelling, net force is 0. Do you guys agree? Now when net force is 0, we call this the case of balanced forces. So in science you have to learn all the terms. Don't get scared by them. You just have to learn the words, and this is where I tell all my students, underline the important words in the book. Don't sit and underline the whole book. But if you see this word balanced forces, underline it. If you see Newton, especially that small n, underline it, right? So this, when you have net force is 0, we call the case of balanced forces or balanced force, right? So that means the forces are cancelling each other. But if an object is moving or changing its shape, then definitely an unbalanced force is there, right? Right? If the object is changing, in change of shape also you could have balanced, because suppose you take a balloon, you apply 5 Newton from this side, 5 Newton from that side, it will not move, but it can be changing shape, right? But usually if the object is changing direction, moving or changing speed, we say there is an unbalanced force acting on it, right? Shape is the case where you could have balanced force. So there is a trick here. Shape could be caused with the balanced force, right? But these ones, the general case is unbalanced. Okay. So usually, so here we can say usually unbalanced. Clear? Let me write forces. Okay, balanced forces. Super clear? So these were some tricky questions here. So force are basically one important thing, one important concept your book teaches, that force is nothing but an interaction between two or more objects. Is that true? So here what is the object? One object you can see is the table. So you can see clearly an object is the table. Can you tell me who is the second object here? And let's say this boy is pushing the table, so clearly there's a push, there's a force on the table. So the force is an interaction between two objects. Who are the two objects? The table and the boy. Yeah, don't think object means only non-living things. Living thing also, like I am also an object, right? So the boy over here in the picture is an object. So this force is an interaction. So basically the boy is pushing the table, right? So boy is applying a force over here, and this is the boy is the number one object. This is the second object. So for there to be a force, you need an interaction between two things, or sometimes it can be more also. Like for example, there's force of gravity. Earth is right now pulling you or me down. So who are the two objects? The earth and me. Clear? When you are squeezing the balloon, who are the two objects? You and the balloon. There is a force, there is an interaction between you and the balloon. When Virat Kohli is hitting the 6, right? Who are the two objects? The bat and the ball. You saw Virat Kohli also, yes, he is applying force with, but that time if you see the bat and ball, or when the footballer is kicking the football to start the FIFA World Cup, between the footballer and the ball, interaction between two objects. So this is very important. You cannot have a force of just a single object, right? Just if there is a ball, there is a force? No. So if you just have one object, you cannot have a force. It's a interaction between two objects, and sometimes you can have more objects also, right? Like in the solar system, if you think the sun and the planets, they are all interacting, right? So here we are talking about or in simple, if you consider a pair of objects, only they can have a force between them. Is it clear? So one very important concept we have learned, that for there to be force, there has to be interaction between two or more objects. And then there is another interesting thing, that the interaction is mutual, right, between two objects, and it is temporary in nature. What do we mean by this word temporary? So when you are pushing the table, there is a force, right, and you can feel it. So when you apply the force on the table, right, there is a force on the table and you also feel that, right? So there is definitely a force being applied. You apply force on the table, table applies on you, and this interaction is going on. Now the moment you stop pushing the table, right, or you stop pulling something, the interaction ceases, which means the force becomes 0. See, the force basically disappears. So that's why we say it is temporary. When you're pushing the table, there is a force. Stop pushing, right? Like when our parents, we're pushing the door or pushing, and the parents say stop. You stop it, the interaction stops. Clear? Is this crystal clear? So in summary, guys, what have we learned? Let's write down our summary. So what have we learned today? Let's jot it down, the important points. Let's write it down. Come on, write it with me. So what is the summary here we have learned? So the important things we've learned today is that force is defined as a push or a pull. Second thing we have learned that force, the unit of force is Newton, the SI unit. And Newton we write with a small n when writing the full word and abbreviation capital N. Then what is the other thing we have learned? The effects of force, right? It can change the speed, change the shape, change the state of rest or motion, right? Or change the direction. So all the different effects of force we learned about. And then we have learned that force is interaction between two or more objects. Okay, super clear? So hope you guys enjoyed this physics class on what is a force, and the concept is crystal clear to you. And do check out the courses on our website manochaacademy.com and our Android app Manocha Academy. All the links are given below. Please do share it out with your friends. As you know, we have courses on science, maths, coding, AI and our IT NEET foundation courses. In our courses, you're going to get live classes, concept videos, quizzes, questions, mock tests and revision notes. So guys, do share it with your friends. Make sure you're subscribed to our YouTube channel. Follow us on Facebook, Insta and X. So stay connected with Manocha Academy and just keep on learning.